This is the Unit 3 review. I'm going to just go through and work every problem off of this review for you so that you're ready for your test tomorrow. So Unit 3 was on sequences and series. We talked about geometric and arithmetic sequences and series. And we talked about how to find the terms and how to find their sums. So this first problem right here asks us to find the next four terms of the sequence. And we're going to have to look at it and decide how we got from the first number to the second number in the sequence. So what did we do to get from 21 to 17 and then again from 17 to 3? Well, we can see there that we minused 4 or added a negative 4. So we can find our next four terms by continuing that pattern. So my first term is 21, my second term is 17, my third term is 13. If I subtract 4 from that, my next term will be 9. Subtract 4 from that, so my next term will be 5. Subtract 4 from that, my next term will be 1. And then subtract 1 from that, and my last term that I needed to find will be -3. So was this an arithmetic or a geometric sequence? This had to be arithmetic because I added or subtracted a number to get from one term to the next. Now it asked me to graph this, and in order to graph it, if you remember, you're just going to write your ordered pairs. In your ordered pair, the first part of your ordered pair is the number of term it was. So you have your first term, and the first term was actually 21. You have your second term, and its value was 17. You have your third term, whose value was 13. Your fourth term, whose value was 9. Your fifth term, whose value was 5. Your sixth term, whose value was 1. And your seventh term, whose value was -3. And you're going to graph those ordered pairs over here on this graph right here. This graph is a little bit too small for me to do on this. So take a few minutes and graph it. And then as you're graphing that, I'm going to just talk about what it looks like. So because this is an arithmetic graph, when you graph that, your graph is going to look linear. It will look like a line. But let's just remember that we're not going to connect those lines together because our domain cannot be the values between 1 and 2 or between 2 and 3, because our domain have to be the term number. So 1, 2, 3. We don't have a 1.75 term. So when you graphed these, you should have had a line that started at 1 and 21 and ended at the last ordered pair that you graphed, which was 7, -3. All right, let's look at the next problem. This next problem is the same kind of problem. This time it tells you it's a geometric sequence. So interestingly enough, it asks you down here, is it arithmetic or geometric? We should be able to circle geometric right off the bat because it told us that. So the question is, how'd you get from 320 to 160 and then again from 160 to 80? You can think about that as a divide by 2, or you can think about that as times by 1/2. It doesn't matter which way you think about it as long as you can find your next terms. So your first term is 320, 160, 80. And then if you times 80 by 1/2 or divide it by 2, you'll be at 40. The next term would be 20, 10, and 5. So again, when we're graphing these, we're going to write our ordered pairs. Our first term was 320. Our second term was 160. Our third term was 80. Our fourth term was 40. Our fifth term is 20. Our sixth term is 10. And our seventh term was 5. And I'm just going to graph those ordered pairs over here on this graph. I'm going to let you guys do that on your own because, again, this graph is just too small for me to write on with my pen. But if you graph this, When you're done and you're looking at it, it should look like a curve, like an exponential function. Do not connect the lines on it. Keep that in mind. Okay, let's go on to our next problem. This next problem asks me to find the sum of a geometric series for which a1 equals 3, r equals -2, and n equals 8. So we're going to first need the formula for that. The formula says a sub n equals a1 times 1 minus r to the n over 1 minus r. And we're simply going to substitute our information into this formula. So they gave me my n value, so I know I'm going to find the sum of the first 8 numbers. I'm going to do that by taking my first term and plugging it into the formula. Where I have r at, I'm going to just put a set of parentheses here, for -2, it'll be raised to the 8th power, and then over 1 minus r. So this is really a calculator problem right here, and I'm making a big emphasis on my parentheses right here because I want you guys to remember that if you're going to put -2 to the power of 8 in your calculator, you need to make sure you put parentheses around that -2 for your calculator to work right. So when you do that, punch it in your calculator, your answer is going to be, when I was punching this in my calculator, I noticed that this r right here that I put, I should have substituted in a -2 right there. So make sure that you did that. I'm sure you did though. So when I did all of the work on my calculator, I got -255. Okay, our next problem again is finding the sum of this geometric sequence. We can tell that it's geometric because we have this number raised to a power right here. That number that's raised to the power is going to be our r value, so our r value is 3. I can find my n value by taking the top number minus the bottom number, adding 1, so 9 minus 1 plus 1, which is actually just 9. And then I can find my first term, which is the other number that I need, by taking this 1 and substituting in place of k. So I'd have 6 times 3 to the 1 minus 1. So if you do the power 1 minus 1, that's a power of 0. 3 to the 0 power is 1. And 1 times 6 is 6. So my a1 value is 6. So again, let's just write down our formula first. We're going to do the sum of the terms. And then the formula looks like this. Gosh, I don't know why I can't write that right now. I need 1 minus r to the n over 1 minus r. So when I take that and I substitute those numbers in, I'm going to have 6 times 1 minus 3 to the 9th over 1 minus 3. That will be the sum of our first 9 numbers. So then it becomes a calculator problem. So just plug it into your calculator from there. Alright, when I did that, I got 59,046. But we all know how I am with calculator work, so check my work on that to make sure that that's the correct number. Okay, this next problem asked me to find a1 in the geometric series. So this time we're still using that same formula, that sum of the numbers, and just going to write down that formula for just a minute so we don't forget what it is. And then I'm going to just substitute in the information that I have. I know that the sum of my first 6 numbers is 252. I know I'm looking for my a1 value. So I'll have 1 minus 2 to the 6th power because the number of terms we have is 6. And then it will be over 1 minus 2. So right now what I'm going to do is I'm going to take all of this part right here and do it on my calculator. Alright, when I did that I got 63. So on this side I have 63A1 and on this side I have 252. Then I'm just going to divide both sides by 63. And when I do that, I get my A1 value was 4. So my starting value there, my first term, was the number 4. Alright, on this particular problem, again, it asked me to find the sum of the geometric series. So I could go back and I could use this exact same formula again. I can find my A1 value, which I know. I can find my R value, my N value, and just substitute it into the formula. Or I could just do this one. This is only to 6 terms. So I'm going to remind you how we can do this one without actually using the formula. Alright, so the first thing I want to do is find how I got from 1/9 to 1/3. How I got from 1/3 to 1. We know this is geometric, so we know we multiplied by something. So if you can't see what it is, if you remember what I told you before, I can take this number and divide it by that number in order to find my common ratio. So if you do 1 and divide it by 1/3, you find out that your common ratio is 3. So my next term here, I would have 1/9, I would have 1/3, I would have 1, and then times 1 by 3, I would get 3. Times 3 by 3, I would get 9. And times 9 by 3, I would get 27. It asked me to go to 6 terms, and I already did go to 6 terms right there. So those are my 6 terms in my series. And then it said to find the sum of it. So really right here, I can just add those together to get the sum of that geometric series for the first 6 terms. So let's add those together and get our solution. When I did the math on my calculator, I got 40.44, and the 44 is repeated. You could also write that, if you left it as a decimal point number, as 40 and 4/9. Alright, let's go on to the next problem and see what we're going to do there. So this finally changes to arithmetic series. So it says find the sum of the arithmetic series. And it actually goes from 2 all the way up to 50. So this is a finite series. It has an end to it. So you can go and find the formula to the sum of an arithmetic series. And you could totally put this information into the formula. Or you could just find the rest of the terms between 14 and 50 and do the math that way. So I think what I'm going to do is I'm going to show you how to do both of those so that you could do it either way you want to on the test. So let's just split this down the middle here and let's go with the first way. So my first term is 2, my next term is 4, then 14, and I need to go all the way to 50. So let's figure out what our common difference was. How did I get from 2 to 8 and then 8 to 14? I added 6. So I'm going to keep adding 6 to get 20, then 26, then 32, 38, 44, and guess what? Oh, I wrote 40 instead of 44. We're 44, and then we're all of a sudden to 50, which is the last term that we needed to be at. So it asked me to find the sum of those. So really then I'm just going to punch them in my calculator to find the sum of that series. So take a minute, punch those in your calculator, and see what you get. When I did that, I got 234. Okay, so if we want to find the sum of our series arithmetically, otherwise we're going to use the formula that is S sub n equals n times a1 plus an over 2. And we're going to sub our information into it. So the interesting thing about this formula, using it, is that you had to find the number of terms anyways. So you would have had to either count them out like this, where we found 1, 2, 3, 4, 5, 6, 7, 8, 9 terms total, or you would have had to do that other formula that I taught you in order to do that. So you would have done the sum of the first 9 numbers equals 9 times A1 is 2, plus the last term, which is 50, and then divided by 2. So you'd have 52 on the top of that divided by 2, which is 26, then 26 times 9, which is 234. So either way you do this, just by hand or by using the formula, it works about to be the same amount of work. But in order to do it this way, over here, we would have had to use that other formula to find our n value if we would not have already had them written out. So just keep that in mind as you're solving. All right, we have a couple of more problems left. This one says find the first 4 terms of this arithmetic series. So if I want to find my A1 value on this, the very first thing I'm going to do to find my A1 value is I am going to substitute in my first value. My first value here is 5. So I'm going to put it in to my formula. So instead of 2x minus 15, I'm going to have 2 times 5 minus 15. 10 and minus 15 is negative 5, so my first term is negative 5. I'm going to do the same thing for my next 3 terms, or until I find a pattern so that I can just use my pattern to find the next terms. So to find my A2 value, the second number I can sub in this sequence over here, I already used 5, so the next number would be 6. So I'd have 2 times 6 minus 15. So 12 minus 15, which is negative 3. My third term is going to be my third value. I just put in 6, so now I'm going to put in 7. So I have 14 minus 15, which is a negative 1. By now, I hope you can see that there's a pattern in these numbers right here. We knew there was going to be. We knew that they were arithmetic. So we knew that there was going to be a pattern anyways. But that pattern that we found is add 2. So if we wanted to just find our A4 value by just adding 2 to the negative 1, then we know that our A1 value will be 1. But if you can't see that, then just simply substitute in that next number and see if it is. That would be 16 minus 15, which is 1. So the first 4 terms of my arithmetic series over here is negative 5, negative 3, negative 1, and 1. Okay, last problem on this review for the test. Now remember that our tests always look like our review pages, so you need to make sure that you know how to do these for tomorrow. And then also remember you can use your review page on the test tomorrow along with a calculator. So be ready for that test tomorrow. This last problem here says to find the formula for the nth term of the arithmetic series, and then it asks you to actually find the 25th term. So we're going to need to grab a formula to do this. So let's look up in our note-taking guide the formula for finding the nth term of an arithmetic series, and let's get that written down. Alright, the formula for that says the nth term is equal to the first term plus n minus 1 times d. Now I have my A1 value and I have my d value. So what we're going to do is we're going to take and we're going to substitute our information into this formula. So to find my nth term, I'm going to use 14 for my first term. I'm looking for the number of terms here, so that's going to stay a variable, and then I'm going to times it by a negative 3. Let's remember that we said when we did this, we need to make sure we distribute that through back there. So my nth term will be equal to 14 minus 3n plus 3, because we distributed that through the parentheses there. Then what I'm going to do is I'm going to combine my terms over here on this side together. So I'm going to have my a sub n term equals negative 3n. And then 14 plus 3 is 17. So this that we just found right here, this is the formula for any term of our arithmetic series. So then I went on to ask you to find the 25th term of this series. So what I'm going to do to find the 25th term is I'm going to substitute 25 in for n. So negative 3 times 25 plus 17. Negative 3 times 25 is a negative 75. And then a negative 75 plus 17 is a negative 58. So negative 58 should be my 25th term of this series. All right, you guys, good luck on your test tomorrow. Make sure you get this checked off with Mr. Miller so that you can have full credit on this.